Hello. Can people hear me?
Yep, we can hear you.
Good.
Hi, Bradley.
Hi, how are you? Hello.
I'm doing pretty well.
Good.
I'm not going to be able to stay for the whole meeting, but I'm excited to be here for as long as I can.
Okay, it sounds good. Hello, Amanda and Samantha and Shaima. Welcome to the meeting. I don't know if Jesse's probably be here in a bit. So I guess first things, there's Sadena. Hello. Sadena is a new person, or she onboarded after the four of you. So she ended up, we met Wednesday. So we ended up talking about a lot of things we talked about in last week's meeting. Then there's Jesse. Hello, Jesse. All right.
Good morning, everybody.
Yeah.
You hear me? Yeah.
Yeah. So, I see. What doesn't? Can you introduce yourself, Sadena?
Yeah, sure. So I'm Sadna. I'm a senior here at UAlbany, majoring in psychology and communication with a minor in business. I've actually, I'm already in a research lab at the moment as well, too. And we do a lot of physiological things, and we look into development, psychological disorders. We work with a lot of physiological variables as well, along with empathy, pro-social behavior. I'm actually a senior right now. I don't know if I mentioned that. I'm also from upstate New York, so been a New Yorker my whole life. Been living in the Albany area since day one, so no big changes as far as college goes. But I was really interested in joining this lab actually because a lot of the work that I do for that lab and a lot of the things that I learned in one of my other T courses for psychology really maneuvered my my perspective into looking into other ways I can adapt psychology outside of the social sciences. So my interests really just follow along the ideology of neuroscience, emotion, behavior. I know we were talking about a lot of this with Jesse and Bradley on Wednesday, just kind of pinpointing where my interests lie and directing how I can work with that. But I'm excited. I want to see what I can do with what I have.
Yeah. Well, thank you for that introduction. And I know that some of you are interested in, I know last week's meeting was heavy in AI, so I didn't want to scare people off with that. But we are also interested in psychology. We're interested in other areas, philosophy, and so the idea here is to, gain an appreciation for the different areas, and if there are connections between them, like I said last week, then that's kind of one of our strengths as a group, is to bring those together and try to do work at the intersection of those things. So I definitely, encourage you, if you find an area that you don't think is sort of your area, still embrace it, and maybe, we can talk about it at the meetings, and then we can find, maybe someone else, one of the other interns or some other person in the lab group can, work with you on it or collaborate. So that's definitely something I want to see, if possible. I think that's a great way to approach this.
Yeah. Two other quick notes I might say just as an immediate follow-up on that. Number one, yes, great, Sadna, to have you here. Enjoyed some of the other interns here from Albany. And if everybody, we'll have time to kind of catch up. We'll maybe reintroduce ourselves in a little bit and go around and talk about our interests and stuff like that. But just bridging off of some of those comments and what Bradley said, two things come to my mind. And one of them is that something that in kind of designing the program that I have had in mind for both mentorship in general. I'm kind of making a mentor program on the side also. And if you're interested in mentoring and helping early career researchers, and some of the things that we've kind of emphasized in a lot of our onboarding meetings so far, that's something you can sort of follow up about and ask us about, because that's sort of its own art form. But there's sort of there's a few different things that play in that whole discussion, and trying to provide you as new people to the lab with context for it is important and also a little bit difficult at times. One of the first things that kind of led down this road was actually a collaboration with an international student when I was back at UAlbany, and we kind of saw a need for. We were looking at like law and ethics and technology, and how a major sort of need in that space was just getting really emphasizing cross-disciplinary engagement in a tech space, because a lot of times technology can be siloed off into, it's like, oh well, here's just like let the computer person do it, and there's a lot of really, you may have heard something called like The Two Cultures by C.P. Snow, which is this classic examination of why, particularly in the West, there's been a major separation among like humanities and what might be called hard sciences, and questioning how that came about over time, and even like looking back historically where that wasn't always the case, and so on and so forth. And so with that thing that I did a few years ago, it was both an awareness of how do we look into that being the case, and how do we actually provide intentional spaces for people who are not experts in every field they're in, but to be around people talking about other related fields. And that's kind of a rare thing, and that's why I really like Orthogonal Research Lab, because it's inherently oriented towards that. And the last few years there's been a lot of work where it's like, you don't have, like, if you're someone coming from a philosophy background, having some light exposure to some of the actual like machine learning, or at least some of the higher level concepts behind like AI ethics. There's something to that, just so you can maybe have a foothold when it comes up. So not that you have to be an expert in it, but you have some context for it. And I think that's actually a really powerful thing to do. And same thing if you're like a computer science person, maybe even especially if you're that in some ways, to be honest with you, because and a lot of like I was one time a long time ago, I was like a business administration major, and I went through a business ethics course at a different university in a different long ago, far away. So I won't really incriminate anybody. But like I was just like, wow, like the state of business ethics and what people in business or some computer science, how they treat these cross-disciplinary or how they treat things outside of their domain. It can be very shocking sometimes to see how much disregard there is for things outside of specialization. So I'm not saying everybody has to be a quote-unquote polymath and know all this other stuff, and there's a large debate in academia and a lot of things about generalizing versus specializing, but there's been some very intentional efforts to kind of create an exposure for that, and in a way creating exposure and introducing people to a space where that exposure and that just familiarity can happen is actually it's an important. I think it's very important, and it's a bit of a strange thing to do, but also I think there's huge rewards to do it, and if over the next coming weeks, I think Bradly and I will kind of be talking a lot about some things that really fit into, maybe not that directly, but that may be a sub-theme into a lot of discussions we have in the coming weeks. So that's sort of first point. Second point, really quickly, we don't have to do this today, but it'd be really cool sometime. I think most of us in the internship program are undergrads, and maybe have only had limited research experience at UAlbany. I think it'd be great to kind of just have a little, I mean, there's no pressure about this, you don't have to say anything, but it'd be interesting to talk about previous research experiences you've had and how they've left you either with some great experiences or questions about research or whatever else. I personally have never actually jumped into a research program that basically started out with the information that I was giving you all. Like we're kind of, this is one of our first major go-throughs of the larger batch of interns with this process. But with the sort of frankness about, hey, here's like the research process in general. Like I actually never really was exposed to that. Maybe other people have been in their labs, and I'd be curious to hear how, when you were brought onto a lab, or like Sadna just mentioned, oh yeah, she's been working in a lab currently. How do they talk about that? Did they? And I had a lab experience in my past where there was like no discussion of any kind about that. And I know that was much more oriented towards, okay, here's like the research game, you know, here's what it looks like, and here's how you can sort of contribute to it or not. So not today, but just planting a few seeds for later discussions on both of those fronts. And I'll leave it at that. So thank you for that bit of a, not really non sequitur, but a little bit of diversion. So back to regularly scheduled programming.
Yeah.
Brad, what did you want to get into first?
Well, I guess I think that's great that we kind of set the expectations there for some of the things we didn't really talk about last week. So I guess I see Amaris is here as well. She's another person who is going to be starting a little bit later in her course of the program. So I don't know if you wanted to introduce yourself, Amaris, or...
Hi, I'm a senior at UAlbany. I'm a biopsych major. I'm not really sure yet what I want to focus on in terms of like topic areas, but I'm hoping to like lean towards more the academic route more than the technical coding route, mostly because I know I'm not good at it. So yeah.
Good. Yeah. Again, we don't want to I know we focus on kind of one thing at a time. Sometimes you'll come to meetings and there'll be like a lot of discussion about something maybe you don't find to be like something you are want to do or interested in or know a lot about, but that doesn't it's just the exposure to these things. And I think Jesse said it pretty well that we want to, this is a little bit different than a typical experience because you want to get like all these different perspectives and sort of integrate them, and it'll take a little bit of time. You'll be experiencing these things, and then it takes a while for people to sort of appreciate where you've been. So you don't just come out of a meeting where you don't like ask a brilliant question during the meeting. It's usually not how it works. Sometimes if you go to academic talks, for example, you'll always have people there who ask really good questions, but for most people, that's not really the case, and that's fine. That sometimes you have to think about what you've seen and think about it in a broader context. It really depends on, the person, depends on, how you're consuming the material. But I think the bottom line is that there's no time scale to that. You can digest it and think about it, and actually that's better because it gives you, I think, a better perspective on some of these materials. So don't worry about if you don't have anything right away to say about it, or if you're not getting it right away. It does take time to make this integration, to make this work. But it's definitely, it can lead to some pretty good things. So I wanted to open the floor. I wanted to ask if people had updates on things that they've been working on, or if they've made some progress, at least just in terms of thinking about what they want to do. I know that I said, you have to present every week. Well, that's the ideal, but I know that people don't have time to like put everything, to get everything together into a presentation or whatever. But I just wanted to know if people. I know Brian gave a talk last week. If people had thought more about where they were going, what they wanted to do, and so forth.
Well, since I can't stay for the whole meeting today, which I'm pretty bummed out about. I'm so sorry about that. Things just didn't work out. I can say a little bit about where I'm at right now, especially since I presented last week, which was super helpful, by the way. I love that model of presenting and then using that to kind of move yourself forward. Right now, I'm just doing a lot of reading, and it's interesting how it dovetails with the conversation so far. Because I have a degree in comparative literature, and now I'm studying computer science and math, and applied math. So I'm realizing as I dig into the technical side of things, how crucial it is to get your thinking straight before you start digging deep into the technical side. I'm sorry, right now I'm even trying to stop myself from getting too technical, but just for a brief second, I'll get really technical, which is basically to say that I'm working on different ways of looking at hybrid AIs, basically, is where I'm at right now. I'm kind of lost in this forest of different types of hybrids and how they're categorized. And, Ron Sun, his kind of laying out of what that field is like right now, or has been for the last 15, 20 years, is really fascinating and totally new to me. And I'm really excited that there are people around who are more interested in the psychology and the philosophy and the cognitive science that drives these AIs, because I think that's really where a lot of the new work needs to come from, and that's definitely where I'm at right now. So I'm just reading.
Yeah, that's good. That's good. And I agree. A lot of times you have to frame things in a certain way and understand it. So, Jesse?
Yeah, I would say that's perfectly fine. That's a great, that's a great update length. And if people if people have to go, so they can't stay for the whole time, certain weeks, that's fine. If you stop in and do a small bit like that, that's a wonderful thing to do. A lot of people reach out to me saying, "Hey Jesse, I'm really interested in this or that. I don't know if I can do a full presentation this week." There may be a sense of pressure about doing this full, big, glorious PowerPoint presentation. Don't worry about that. A great thing that Bradly said to me one time, I immortalized in a tweet, which is a big deal these days, was something along the lines of, in research, sometimes or often, or in research, generally speaking, progress is more important than results. And is that what you said, Bradly, basically?
Probably, yeah. I don't remember, but
the point of it was, it may not seem, or consistency or inertia or momentum, perhaps, is more important than results. So one of the things that I think is really important and that I haven't really seen, and this even ties into some mental health and grad school and research. There's a whole conversation to have about how tough it is when you're doing research, because so many things are externally validated, and what can you do when you don't have a big, I got all this data set that's refined and I'm ready to publish my paper. Great, those are all very, very down the road things, but in the day-to-day, a lot of it's just what can you do to keep your attention and your momentum and your inertia on things. So these little updates are actually a big deal. It may not seem like it, but just being able to say, hey, here's what I'm working on, that's actually a lot. So don't underestimate being able to just say, hey, I'm working on this, and I think that's a major thing coming out of undergraduate too. Like there's such a focus on, okay, get this paper done by the deadline and show us. In research, and especially in real world research, like that's purely research oriented, there's different environments where it shifts a bit. But like a lot of times deadlines are very important in a practical sense, and in a real research sense, totally arbitrary. They are just, research is very nonlinear times. So many people have said, oh, I don't know about doing a full presentation this week, and that's fine. If you give us a little update like that, that's great too. So no pressure,
Yeah.
but mild encouragement to keep talking about where you're at. And no amount of like, oh, I read 50 papers this week, is that enough? Like, some weeks you can read 50 papers if you want to, and some weeks you're not even going to come close to that. Like, don't even.
Yeah.
Anyway, enough about that. But would anyone else like to give a brief update about what they've been at or looking at this week?
I can give an update if you want.
Okay.
Hey, Sam.
So hi everyone, I'm Sam. It's nice to see you all on my screen again this weekend. So I've decided to focus my research on understanding the empathy of artificial intelligence. And the main reason I decided to focus on this was because as humans, we're very empathetic and we respond well to emotions. And as artificial intelligence becomes more advanced and jobs start becoming more automated, artificial intelligence, at least in my opinion, has to catch up and match our emotional health and our emotional intelligence to relate more to humans. So that's mainly the reason why I wanted to focus on it. And this week I've started to scan through Google Scholar and other websites and articles to find good sources to hopefully match my research or disprove the question that I'm trying to answer. So that's kind of my update.
Great. And what's cool about updates, especially at this point, like there may be other people in the lab who are interested or have experience in that. Like some things that other people will mention and speak during onboarding maybe fit with that. Like, and have people may have experience in that area or cool things they read. So it's a great way to talk about it. Yeah, like Sadna, you were raising your hand.
It's actually really cool to see, Samantha, that you're working with empathy and how that connects to AI, because I'm actually also working with empathy in a different lab, and we're just kind of figuring out how to code it in human behavior. So it's interesting to see like how that works in terms of like understanding like what direction like empathy can take and like what you would consider that, or just like how you would define it, because there is a fine line between like empathetic behaviors and like how you relate that to decision making. So like I'm like that's really interesting that you're doing that with AI, and like I'm excited for your work.
Thank you. I might reach out, if you say this lab is important, maybe I'll reach out to you and see if you have a human perspective, if you're cool with that.
Yeah, I'd be totally open to that.
Great.
That's
Yeah,
great.
and that's sort of like the point of magic of like cross-pollinating stuff. Yay, Ankit. The I don't know, will you be able to stay very long, Ankit? Or yeah, it's great that you're here. Ankit has been with us for a long time, but hasn't been the last meeting. I think it's the first time this year we've seen you in meetings, so great to have you here, Ankit.
Yeah, I'll be there for like 15 minutes, like around that.
Okay, I'm just happy to see you here. So
Do you,
if you want to give
Yeah,
us
do you have any
updates
updates?
of your own, or, yeah.
Yeah, so like I've been like working on like speech recognition for some time, and it's like really interesting to know about like what challenges you have. So it's like the times when you go in like wrong directions, and like my advisor has had to like point me in the correct directions with some. So I'm really learning at the moment like how like research is being done at like actual like research centers and stuff. So it's really great. And like currently like I'm really working I'm working on like the old techniques, but it's really good to like know about the old techniques, because only if I know about them and like the problems associated with them, like it sometimes like it happens that your supervisor would give you like stuff and you would think like why this we are using such techniques, but it is often that I realize like while working that like sometimes like the techniques that don't work, even if you use them, you get to know a lot about that. So it's mainly about that, and like I've been doing a little bit of bash scripting. Yeah. So like this is like an updates on what I've been doing.
Yeah, it's great to hear from you. Just so, for those who have never met Ankit before, Ankit is really interested in machine learning and applications. He's very interesting Twitter updates, and he'll find a lot of cool stuff, and he'll tag the lab and me in cool stuff. So, great person to know for that. If you ever have any questions about those areas, Ankit's a really cool person to talk to about that. And yeah, we've collaborated on a bunch of things in the past here in the lab too. So good to hear from Ankit again. You were going to say something, Bradley?
Oh no. I was going to say that Ankit and I recently worked on a paper that Ankit kind of had. He had the research that he had done, and then we worked on writing it up as a paper and getting it out. And so we've submitted it to Gecko, which is a conference for evolutionary algorithms, and getting the paper in shape so that it's it presents everything in the right order and is clear. And so these are the kinds of things you can do here. You can bring existing work and we can work on it, or you can explore your own topic. It's just a matter of like this place gives you the opportunity to sort of interact with other people or interact with people who, I know some of you mentioned, that one skill that you wanted to develop, I think this was at Wednesday's meeting, was to work on like literature review and building a paper and doing that. And I think that's a wonderful skill to sort of focus on, because that's a very good skill to learn, to have down that process. And, sometimes it makes a difference between like getting a paper published and not. If you have that skill, if you can like take ideas and synthesize them and present them well to people, it's ideas that people may just reject because they just can't understand it. If you can present it in the right way, it makes it easier for people to accept. And so that's one of the things I think and I know that maybe you don't think of that as a skill, but it definitely is. So
yeah. A quick piggyback before we continue with updates. I'm on the fence about like having interjections or not, because of great segues. But I don't want to feel like we're not giving to people. But very quickly, I'll say, if anybody saw the deliverables video that I made, you didn't have to watch it because I basically already went over it. But if you wanted to recap, it's a nice recap of like starting out as a co-author, leading a project, leading a research team, different roles that you can have as for like your level of seniority or your level of interest in a topic or your familiarity with a topic. And starting out, like a lot of first-time researchers are going to be starting out as co-authors or just collaborators on a project, and that's totally fine. But then also like the layers of like internal things in the lab, like internal blog posts and internal lab presentation, what's a flash talk or a longer talk inside the lab, in-house. Like that's kind of it's the tutorial of the video game. It's your safe space to experiment and say things that are totally experimental and try and fail and say things that you don't like and then, I don't like why I said this, and get better. Like it's this great practicing and really important. And then maybe articles or other less pressure situations externally that you get into, discussions and invited things, and then going all the way to like papers and conference presentations as a sort of tier of your deliverable you're focusing on. And one adjacent thing to that talk, and what's kind of popularized now maybe as science communication, and also not today but some other time I'll go through the concept of like demo or die or deploy or die, which is like as a researcher, and especially if you have a career in research, but this is also really it's extremely important for everything you do in branding yourself in your career. This is an extremely transferable skill that I'm going to talk about right here. Was like, how do you get experience communicating core concepts to different audiences and know what their level of interest is, their level of familiarity is, and how to convey importance. It's totally a practice skill. The more you do it, the better it is. And starting out with just getting used to it, I've said that so much, but it is a big thing. So more, again, I'm saying this now, we'll come back to a lot of this in the coming weeks, guaranteed. So, okay, thank you for the update, Ankit. Great to see you here. Ankit and Brian, if you both, if you can, and just everybody else, if you could come only for a little bit, let us know. Let us know, like, hey, I can only, I can only come to the second hour of the meeting, but I wanted to present something. Just let Bradley or me know that, because we can say, okay, Jesse's only going to be here for like the first half an hour, and I want to do a little update, so we'll make sure we'll give you time to do that. So, great to hear that. And yeah, hear from you, Ankit. And anyone else would like to say a brief update, or I don't think anyone has said, hey, Jesse, I want to do a flash talk or a short presentation today specifically, but let us know if that's the case too. Anyone else would like to share where they're at or what's on their mind with the project? Okay, I think that may be it for people who want to say things.
All right.
Going once, going twice. Okay. What were you going to say?
Oh, well, I don't know if you had, I wanted to move on to some other things, but if you had another thing you wanted to say.
Oh, just like things that I would like to talk about today in general for myself. I think I need to spend a little bit of time today just mentioning some things for the New York Celebration of Women in Computing, NYCWIC. I don't feel comfortable with that acronym for some reason. But just to kind of say, hey, this is happening. So I might spend a little time on that. There's a lot of external things that I could update on. I happen to go to a number of talks the last 2 weeks, and I haven't really talked about any of them here. I would like to also talk. I'm gonna do an update that's not really an update. I would love to have had a more refined presentation about my frontier map stuff, but I don't have that today. But I'm still going to talk about it. So I'm gonna ride that line myself, and you're like, oh geez, I wish my presentation was awesome, but it's not there yet. But I'm still going to talk about it. So those are things that are on my mind.
Ethics talk and with Timnit.
Yeah, I was. Yeah, that's one of the things that I was going to mention briefly, because that was really cool. And there's a lot of overlap between her story and why she made DAIR, Distributed AI Research Institute, is very cut of the same cloth as part of why we're in this. Why we're here. So. But what did you want to talk about today, Brad?
So yeah, why don't I go, I'll show people, actually I wanted to talk about, speaking of research, I wanted to go over some things that we have and kind of show how things evolve from project to project or from submission to submission. And so I'll do that. So, wanted to make sure that we're, checking out the Slack, not just your intern channels, but, exploring some of the other channels. So we might go through some of that. And then we'll maybe get into some other things. Actually, I did also want to mention that we're, I know on Wednesday's meeting, the people who were there, I showed you this page where we had our Google Summer of Code projects. So, and I know Ankit's interested in Google Summer of Code. So we've officially applied as an organization to Google Summer of Code. We've in the past applied through the INCF, which is the International Neuroinformatics Core. That's what it stands for, INCF, and they've been very good. But the problem is we haven't gotten a lot of slots through there, and it's limited by how many they can get, and then so we've decided this year. I had some sponsorship from the INCF to apply as our own organization, and if we don't make it in as an organization this year, we'll still have the projects hosted as like under INCF. So that's not a problem. But I think having our own organization, yeah, thanks, Ankit. That the advantage is that we have more latitude in what we can do. So why don't I share my screen? Yeah, so Ankit, that was his comment. Let me share my screen. Okay. So the first thing, you can see my screen here. Yeah.
Yeah.
Okay.
I've been having trouble with screen sharing, but yours is working just fine.
Yeah. So the first thing is this is our sort of page for displaying the project. So if you're interested in our sponsorship, I've created this umbrella organization. So it's things going on in this group here, but also things going on in what we call the DevoWorm group, which is in conjunction with the Open Room Foundation. And it's another meeting that I run weekly. So we talk more about developmental biology and biological complexity and things like that. So this is a different group, but we have projects under that umbrella as well, or those projects are under that umbrella. Then the Rockwire Community. So Rockwire is a smart, healthy communities mobile app type organization. So Rockwire is a platform that they've built these campus applications. So it's like a smart campus type applications. But there's a broader interest in these, what they call smart, healthy communities, which is where you basically take like a city or a campus and you instrument it with informatics and with things that people can check, like mobile devices or dashboards that allow you to make better decisions. And so that's a long way of saying that there are a couple of programming opportunities here. One in building community and perhaps some of these smart, healthy communities projects. And another one is for like working with the API for the architecture for the Rockwire platform. So those are both opportunities. In terms of DevoWorm, we have this interesting opportunity. I've already gotten some inquiries about this. This is using graph neural networks as developmental networks. So this is where, the idea of this project would be to take biological data, microscopy data, and other types of biological or developmental processes and encode them or embed them as these graph neural networks. And so we have in the DevoWorm group, we've talked about developmental networks, things like what we call embryo networks, or connectomes that are developing. So connectomes is they're adding neurons during development, and so we have those representations already. The idea would be to create embeddings that are graph neural networks, which are a specific type of neural network, but being inspired by those biological networks. And so then that would give us a toolkit. And we already have software for like extracting and understanding the network data, biological data from microscopy images and other sources. So if we can take that and then move it into these graph neural networks, or at least have a connection there, then we have these representations for which maybe we can do simulations using graph neural networks. And then that would be really interesting in terms of facilitating some really interesting simulations and other things. So, people are trying to, people talk about using neural networks as sort of like a simulation for the brain. We're kind of interested in that, but we're also interested in sort of really kind of getting down to the biologically inspired aspects of that, building these models and then maybe if we use that approach, we can gain more insight than what's currently in the literature. So then there's this other project on taking some specialized microscopy data and building spherical representations of an embryo. And so this is something that, if people are interested, they can check into. The project from this group here is this collective cognition model for AI ethics. And I know some of you have seen the AI ethics channel, but I would really encourage, especially if you're interested in philosophy or like empathy in AI especially, to check out our ethics, technology, and society channel. So that is here. I'm moving over to the Slack again, if I can get it to go here. There we go. So we have this ethics, society, and tech channel, if it wants to behave. And so we have a lot of things going on in here. But one of the, it looks like we've got someone joining there. But there's a lot going on in this project, and I would encourage people to think about, those sorts of things in this framework. So this project is actually a twofold project. One is to sort of define like sort of a regulatory model for looking at behavior in open source communities, looking at how people contribute and how people sort of reinforce maintenance in open source projects, and reinforce virtuous behaviors. And then the second part is to build agent-based models, and to model some of these behaviors in collective behaviors, and then go back and validate the regulatory models. So it's a two-part project, and it draws a lot from things like the ethical regulator, which is something that is a concept based on cybernetics. There are also some other maybe some opportunities to employ reinforcement learning or some of these other things. So this is the project. I think Cheyenne was in the meeting last week. I know he's interested in this. So definitely this is something that we'll want to talk about more in the coming weeks. There are two different project types. There's the 350-hour project and the 175-hour project. The 175-hour project is the typical length that we've had in the past. So that's been over the course of a summer. The 350-hour project, of which this one is one, that's a longer period that can go into the fall. And they're trying to be flexible because people are pandemic and post-pandemic people are, wanting to be more flexible in some of these projects. So they're doing that as well. So definitely this is a longer term project. We'll have, a lot of flexibility in how it works, how people approach it. And then there are opportunities for people to feed into this. So this project is just kind of an outline of something. If we want to insert things into it, like people are interested in like the ethics or philosophy of this, we can certainly explore that and build and use this as sort of a framework. So that's then, and we'll hear about this if we're accepted as a project next month. But if we're not accepted as a project, then we can, of course, host it under INCF. There's no guarantee we'll get slots if we do that, but that's our plan. And then this GSOC program is really nice because it's really led to different initiatives in the lab. So our GSOC projects in the past, not only here but in DevoWorm, have led to a number of long-term projects. So DevoLearn was something that we started in 2019 with this idea that we wanted to create pre-trained models for analyzing data. And so it moved to 2 Summer of Code projects back to back over the 2020 and 2021. And then last year we published some software on this. That was our, the outcome of those projects. And so we had that. Developmental Bradenburg vehicles, I think I talked about last week. That was a group effort where we have several software packages that came out of that. And this contextual geometric structures, which was something from 2018 that, again, we have a couple of software artifacts from that. And so, we can create software artifacts, we can create papers. The software is all open source, so people can go back and modify it if they want. So it's a nice way to build upon, to build knowledge in a certain area and to build tools as well. So that's our summer of code, and I bring that up not because I want to force everyone into coding, but because I want to show that those things are serendipitous in that they can lead to other things as well. People have ideas that branch off of that. We certainly want to go in that direction, or we can go in that direction. So, okay. I don't know if we have any questions on that. Okay, it looks like... Okay. So, yeah. I created an umbrella organization, too. Okay. So...
Yeah,
Oh, go ahead.
I was going to say, I think Brian had to drop out, so that's
Okay.
cool.
Yeah.
And I may follow up on that umbrella organization later. It's a semi-joke. But I'll
Oh,
leave it there. But yeah, no, that's great. I'm actually I'm excited to. There's a lot of new things that are happening in the lab right now, and if you're around, you can participate in the Google Summer of Code related projects without doing any coding, by the way. That's basically what I did my first year. My first time here, I came in I found out about the lab through Google Summer of Code. And I didn't really code anything my first summer I was involved in the project. I did a lot of other things. I paid attention, I showed up to meetings, I collaborated on papers, I read papers, I reported discussions, but I didn't straight up code anything in any significant. I did some things on my own, but think mostly about the concepts, I would say, and don't feel necessarily like, oh, anything coding related I don't want to be a part of. We can, if you're interested in learning a language, we can talk about that too. But don't be put off by the fact that it says Google Summer of Code. There are ways that you can be around it if the concept and the topics are interesting to you.
Yeah. And in terms of code, I mean, that's not actually why you're here, because you can learn how to code, there are tutorials and things that get you up and running, but this is, more like, then what do you do with it? Or what do you do to interface with people who know how to code? Because, you have an idea and they have, coding. So, Ankit is very good at, building, running machine learning models and running genetic algorithm models and things like that. So, maybe someone wants to collaborate with him, say, on something where they have this idea that they want to define down to maybe a simulation or something, or, put it into a machine learning model where, you can run it on your own, but you don't know what the parameters mean. And, it's like, that's the thing about expertise in academia is that, you have some people who become really good at some set of things, right? And then other people are good at other sets of things. Sometimes to solve a problem, you need to bring those people together and really kind of draw from each other's expertise. And that's really where that's a nice area to be, because you can do a lot of really interesting things.
Yeah, and part of what I said, the very first thing I said in the meeting today is there's a whole way of interacting where, and this is something literally that I do all the time, both here in the lab and professionally in one of my actual jobs. There's an art to learning how to deal with people who are experts in a field you know nothing about, but there's a way to kind of get a limited overview of what they're doing and how you are interfacing with what you know or what you're trying to do within the project. And that's I actually wish this is one of the things that I think is least talked about in my overall development, like in academia, like this was never really stressed, and it's kind of alluded to it like in a business or like professional development sense, and that's part of why I've been focused on it. But I really think it's something that should be explicitly stated more often. So whenever it comes up, I'm going to really say, hey, this is keep this in mind, or like, you know, keep label this, or keep like tag this conversation with, you know, cross-disciplinary, multiple levels of technical expertise or domain knowledge expertise, and keep building the context with these like threads that I'm trying to weave with those remarks. So again, more of that to come. But great.
Yeah.
So I'm excited about a lot of things happening in the summertime.
Yeah. So I wish Brian were here for this next part, but I can send him the link to the part. The next thing I wanted to talk about is this paper. So I think I mentioned last week that we're working on a paper for A-Life. So the submissions document is, I think I showed this last week, where we have all these different opportunities that are coming up. So, you know, you have things that are past, things that are like maybe we didn't make in time. And the next set of deadlines is like right around March 1st. So, you know, March 1st is this conference, A-Life 2022. So that's coming up in a couple weeks. So, you know, this is the New York Celebration of Women in Computing. And this is the deadline for the presentation. So the abstract has already been submitted. So there are these milestones that we have to meet. And so for A-Life 2022, there's this milestone of March 1st. And March 1st is... the first, in this case, we need to produce a paper, or I'm mostly involved in this. And then, you know, it gets reviewed and they accept it or reject it with revisions. And then you get to produce you have to do the proofs on the paper, then a presentation. And if it's not accepted, then you go on to another venue and you try that. But the idea is that you have these milestones. And you have to meet all of them, you know, until you get to the conference, or sometimes it's a publication. It's the same thing. So, you know, this is a matter of keeping time, and really, but I mean, keeping time in the sense that this deadline is coming up in 3 weeks. Let's work on it every day a little bit so we can make that deadline. Sometimes you have to prioritize things, and sometimes, you know, that's why you focus on one thing at a time, but you always keep other things in the background. This is a skill you're going to learn. Like it may not be apparent how you would do that, and people have strategies for this. But I mention this because, you know, look at all these things that we have here. Now, you know, it seems like really overwhelming, but if you think about it, you know, if you have a good plan of attack, this isn't so overwhelming. So, you know, in January, Ankit and I were working on this Gecko presentation and this paper. We don't have the presentation, but we have a paper. And so once that's evaluated in the peer review process, it's either accepted or rejected. Now, if it's accepted, then we would have to produce a presentation on it, and then you would present it at the conference. With A-Life, there's this deadline of March 1st. And so the question is, what do you submit? And so actually I have to update this because this is, and I'll show you why. So there's actually two things that we're working on, or I'm mainly working on for this, and I'll bring other people into this soon. There's this dual inheritance model work, and then the layering and folding work. And I'll show you the layering and folding work here. So this is the layering and folding work. So this is a paper that I'm putting together. This is based on some of our previous work, but also, you know, sort of an idea that I had for this conference. This is a conference I really like. It's a nice conference. It combines computer science and living systems, biological systems. So they're always on the lookout for things that are biological but also computational. And so this paper is actually, it's a weird title. but it's not, because it's actually quite relevant to the current literature in different areas. So the title is Layers, Folds, and Semi-Neuronal Information Processing. So what does that mean? That doesn't sound like anything that you're maybe familiar with or anyone's familiar with. So the idea here is that you have in biological development and in biological systems, including your own body, you have these two things that occur in development and then in the adult phenotype. And you can check yourself, believe me, this is true, that you have layers of tissues. So your arm, for example, is made up of different layers of tissues. You have skin, you have fat, you have bone, you have muscle, and all those things are layered. They're just not like arranged in a mosaic. They're layered in as structures, like muscle fibers, fat pads, skin, that goes over your body and, goes over all of that. Bone, which is, organized in different ways. It can be, long bone, or it can be cartilaginous bone. But they're all layered in a way that's functionally integrated. And so that's one part of this. And then the other part is folding. So if you look at some of if you look at your hands, you see that your knuckles, right around your knuckles, you have these folded pieces of skin there. And that folding is actually functional because you can move your fingers and the skin moves with it. It doesn't tear. There's slack in the skin, and then if you pull your fingers down, you can see that those folds kind of become less prominent. And so that folding is actually functionally relevant. It allows, in the neocortex of mammals, you have this folding that also occurs, and it's because that neocortical sheet is grown in humans to a size where it can't necessarily fit into our skulls unless it gets folded up. But that folding of that tissue then has functional consequences as well, communication between neurons and things like that. So all these things, these two things, I'm relating them in this paper. And so at this stage in this paper, and I bring this up in this state because I wanted to make a point about writing a paper and getting an idea like this out. So the first thing you'll notice is that this is my style of this. You might operate from a strict outline, but what I've done here is I've tried to pull together these ideas. I've got an introduction that's kind of half written, but the idea is I'm trying to bring in some of these examples of layering and folding from different systems. And then I've brought in some literature there is actually a nice literature, which I just found out about the depth of it last night. So I'm working on this currently. But there's this nice literature on layering and how layered structures operate. And so there's a lot of really interesting work in the past on not only in biology, but there's a little bit of work in computational agents. But they have these things called layered control architectures. So layered control architectures are architectures that have different layers that are functionally distinct, but they interact during development or during function, and they regulate one another. So there's this regulatory component. So I find this really interesting because this is exactly what we're talking about in here. And then at the end, we talk about this idea of what we call a metabrain model. And this is a paper that Jesse and I put out on the archive. And this is about agents that have layers of, let me see if I have a figure here. They have these layers that are representationally distinct. So you have, say an agent has 3 layers. This is a 3-layered metabrain. The lower layer, or the lowest layer, has the least representational content. So it could be just a plain neural network that doesn't have any sort of symbolic representation going on in it at all. Then the next higher layer is something that has a little bit of symbolic capacity, but it's largely connected to this one, and maybe it's running off of this in terms of this is a neural network, this is another network that has a little bit of symbolic capacity, and then this top layer is a totally symbolic layer, and it doesn't have to be a network. So those 3 layers interact. So that's what a metabrain is. What we're doing here is we're combining this biological concept of layering and folding with this metabrain, so that you get these three-layered structures that then fold up in a certain way. And these folds actually have some functional relevance, not just the layering, but the folding. So you have these three layers that communicate. Then as it folds, this topology in space actually means something, and it allows it to do things. So like in the body, you know, you have layering, and then that layering can exhibit folding, and that could mean a number of things. That could have a functional significance. It could enable movement. It could enable processing in different parts of the body, those sorts of things. This is very abstract, by the way. But the idea here is to, like, first of all, what was that?
Nothing. That
Okay.
was a different sound.
Okay, it's fine. So let me go back to the top and let me kind of lay out what you've just seen. So you take an idea that, you know, you might think is kind of out there, and then you sort of organize it into this outline. This isn't like, you know, the typical outline where you have A, B, C, and so forth. This is an outline where I've basically said I'm going to build an introduction. I'm going to write up like some introduction to this concept, that there's layering. You see this in biology. There's folding. You see this in biology. Then there's this literature on sort of this control model of layered control architectures. Then, you know, we move to applying some model, and this is going to model the mammalian gut. So this folding that you saw in the previous figure, the gut, when it's in development, it actually folds. It starts as a mass of cells, and then it folds. It does this thing called invagination, where it folds inward. And then that inward folding creates this sort of chamber, which then becomes the gut. And the gut is, of course, your digestive system. Most organisms have a digestive system with a gut. And then what actually happens with the gut is that it becomes what they call a mini brain. So a mini brain is this thing that like has neurons in it, and it can sense things. And your gut actually can sense, you know, when there's food in it, when it's irritated, and so it can respond to the central nervous system appropriately. So there's this autonomic control. And so the gut is a nice model because it's a mix of neuronal and non-neuronal processing. You have this sort of physiological processing, but also stuff that goes to the brain. And so that's you know, laying out that introductory idea, connecting it to something that's not as abstract, and then going through and reviewing the literature. So all these numbers here are citations. And, you know, this is a matter of finding things in the literature. So when I went to the layering literature, I had found a paper actually last Christmas or over the holiday where it kind of talked about, it looked very similar to our original MetaBrains paper. I open it up and I find out about this whole field. So as I'm going through the paper, so then I'm following up on those citations, going through their list of citations, finding out more about these papers. And so now I'm able to write this summary of what I found, putting in these numbers as citations, which are down at the bottom. And now we have this nice literature review. So then the next step is to go through some examples of layering and folding. We see it in embryogenesis, which is in the embryo. We see it in skin, we see it in bone, and then in brain anatomy as well. And, you know, again, you go through the literature, you find examples, you cite them, and I'm not done with this. This needs more citations. But, you know, each, and then for folding, you see the same thing. It occurs in the embryo, it occurs in cortical sheets, it occurs in these forms called rugae, which are folds within, like, the intestine or in on the skin. So there are different places where these occur. And so we have this, we just review these examples because they're useful in showing the diversity of what we're talking about. Then we get into MetaBrains, which is this computational model that we're using to look at biological information processing. So we're looking at the gut, which is a mini brain, It forms the core of what they call the enteric nervous system, so which exhibits both this layering and folding. So we have a nice model system that we've picked out here. And then this is, they go through like kind of how the gut forms in development and why folding and layering are important. And then, this is the diagram of the metabrain as it, would look. So you have this 3-layered thing. It looks like a Neapolitan ice cream layer on top. How it has like the 3 flavors of ice cream and they're striped. You take those set of stripes, you fold them over in different orientations, and you get your what you would, I guess, is the analogous. It's analogous to invagination. So there's this hole in the middle here, this chamber, and then this is the sort of the topology of the gut. Again, this is all very abstract, and then this is how the function would work. There'd be a functional relevance to this topology around in space, and so that's the idea. And then kind of going through some other technical details. This is the thing about research papers, is that it's often a struggle to figure out where to put pieces of information. So you want them to be self-contained. Like you want a paper to have like technical details. You want it to have like a literature review. You want it to have like, relevant information. You don't want to go off on too many tangents. You want to deliver that. In this case, we need to have 8 pages in a format that is, I think in this format that I have it now, it's like 12 pages, but you have to fit that into a different format. So there's a space limitation. And so all those things need to be taken into account. I'm leaving notes here for, we're going to expand different parts. So this is very much a work in progress, but I just wanted to show what this looks like, this process in the raw, what it looks like. I don't want people to think that these things just pop out very refined. That's what I want, the thing I want to impart here. Then there's a discussion section. So this discussion section, of course, then ties back a lot of the things that we've talked about in the paper to a broader context. So in this part, we talk about representationalism and how when we talk about metabrains having different representational capacities in the different layers, this is not something that is limited to just in cognitive science, in cognition. People in the artificial life community have actually considered this in terms of biological representation. So they found this. I found this reference by Halpin. I think I put it in the Slack, where they talk about representations as this physiological thing. So this is representations in physiology, as opposed to like mental processes, actually refer to things like emergence and other types of components of the system. Again, when you cite a paper, you want to be accurate, but you don't want to just you want to paraphrase it. You don't want to just throw in a passage, because that's considered to be plagiarism, right? And so you want to be able to paraphrase something, and you don't want to go on forever, but you want to get it in there and you want to make the point. So in this case, we want to make this point that biological structures also have representations. The nervous system also has representations associated with it. And so when you combine these, it's really interesting. And so that's the idea we want to communicate. And so then, this kind of summarizes and gives us maybe grist for some future directions. And that's basically what you want in the discussion section. So again, we have the references. These are organized. You have to format them, as you probably know. But you want to also, in this case, the format is to number them. So sometimes you put them in alphabetical order. Sometimes you number them like this. And I have to fix the numbering in some of these, but I often do like interval numbering, and then I fix it later. So it's like going back and renumbering it. But, you just want to really have a nice set of references. Don't think you oversight, you don't want to, you never oversight. You want to cite anything you're in doubt about, whether you should cite it, just go ahead and cite it. And, that's better, because otherwise you're kind of like, people say, well, where did you get this from? This idea is interesting. Where did it come from? The reason we do citations is because we want to make sure that people know where something's coming from. Well, we also don't want to misrepresent that citation because, it's obvious that, it can become obvious to people who read the paper, and it doesn't make you look good, but also it's misleading because people use these citation lists. Like I said, I saw this paper, I think it was a Wilson and Prescott here. I saw this paper, and then I dug into it, and I dug into the references specifically when they said that there's this layered control architectures literature. I wanted to go and find out as much as I could about it. So I went to the literature, and the way I accessed it is through their citations. So if they made a bunch of mistakes in their citations, I couldn't do that. So that's why it's very important to do things like that. So, there are a lot of ways, you can approach writing a paper. That's the way I do it, and it works well for collaborations. What we do in the lab here is someone will, like Ankit has done this, where he had this paper. It was pretty rough. He wanted to, make it better, so we worked on it. And then, we share this document. We'll go back and forth. We'll put notes in. We'll make changes. We use Google Docs, so it's all the changes are all tracked, so we can go back and decide what the best course of action is. So that's a very exciting way to do that. So I just wanted to go through that paper. I wanted to show you a very rough version, and then I'll show you when it's done, so we can compare that to this version that I just showed you. So why don't I go to the comments, because we seem to have a lot of comments here. So, first of all, does anyone have any questions about what we talked about? I know that was a lot. Okay. Well, so let me get into the chat. And there's some questions in the chat here. So, this is genotype, phenotype. So, genotype is what your genes say. Phenotype is how things are expressed in an environment. Yeah, so some of the work that we do in the group is we talk about AI and agents, but we take an approach where we kind of consider the genotype, and we can create what they call a genomic encoding, which is where you just basically have this very rough model of defining what the sort of innate properties of an agent are. And then you have a phenotype, which is the body. So we do a lot of work with embodiment. So that relationship is actually quite important to what we're doing. In neuroscience, I know people talk about genotype and phenotype all the time, and it's a little bit different there because you have an actual genotype that moderately little about, let's say. What the genes are, how they're expressed, but you don't necessarily know much else about it. So, and then that the phenotype has features, and there's maybe an association between the two, but it's not very clear what those are, especially in some behaviors. So in an agent, we can clarify those relationships and make them, and kind of create I don't want to say a false model, but it's a oversimplified model to show how that relationship might work. And so that's one of the things we do. And that's kind of what is in this paper about, that kind of relationship. So that's definitely something, those are, something maybe, we can talk about later, that relationship. So the set of observable characteristics of an individual resulting from the interaction of the genotype with its environment. Yeah. So usually that's the way that people think about the relationship between genotype and phenotype. And there's a lot of stuff in between there, like hormones and developmental processes and physiological processes. But that's something, when you make a model of the brain, or when you make a model of an organism or anything, you oversimplify it on purpose, because if you put all those parts in, it would be unwieldy. So we build models actually that kind of get a little bit creative about that. What do we want to include in a model of an organism or behavior? Do we want to include a genotype, and say it's just, it's like a genetic algorithm where you have this model of a genotype that's just being expressed? Or do you want to not bother with the genotype and say that there are fixed behaviors? Or do you want to have, we've talked about Bradenberg vehicles in the group, which are models where you have like a connectome or a little brain inside of a vehicle, and it runs around, it exhibits these behaviors based on this very simple model of a brain, which is just like the little neuron units and their connections. And a real brain, of course, would have a lot of different things in it. But that's the what we call the abstraction of that. It's just a very simple model, and it demonstrates principles. It isn't going to mimic the human brain, but it's going to give you that insight. So Jesse also said, interesting thing from Johan plus Paul Cizek talk last week, which is we have talks that people have outside of the lab, and Jesse's very good at spotting these. They're usually on the internet, they're recorded, and there are a lot of different talks. Johan John runs a talk series that you might want to catch up on. He talks about a lot of different things in neuroscience.
Yeah, if you're like interested in generally things we're talking about in this lab, and you really like biology and neuroscience, I'm not a pure biology person, but Johan is like academic role model for me. Like I wish, like the way that he can communicate and the way that he's so passionate about exploring ideas, and he's one of the most genuinely interested persons I've ever met about let's talk about this and understand this, and he's very inviting and extremely knowledgeable and is a great writer. So if you're interested in anything like from a neuroscience perspective, I can totally either get you into those journal clubs or just point you at Johan's extensive writings. And that can easily, anything that he works on can 100% easily be incorporated into a project for our lab or potential I don't know. I can't say you can collaborate with Johan, but like we can do things that are working in the same vein. He specializes in like emotion and disorders, but he's super interested in concepts and from a biological background. I love it because he's what I want someone to be that I can't be. I don't have a lifetime of biological training, but he does. And so from that perspective, he branches into evolution and cognition and emotion and a lot of those things. That's great.
Yeah. So Ankit had a comment about like creating a Medium blog post on some terms that we use, technical terms that we use, and I think that would be a good idea. So maybe I'll work on that. I want to go through things that are very. I don't want you to worry about terms so much. Like when I introduce something, I want you to get like kind of these ideas about like how to, the process, and then we can talk about the terms. But I think it would be nonetheless probably good to have some terms defined. And this is always a thing in science too, is that you have, or in any field, is you have these terms that people use, and sometimes they're very specialized terms that you create, and sometimes they're things that are just kind of technical terms that people debate the definition of. So it's always good to have like, a list of terms with you if you're talking about any field, or especially you're crossing fields, to have the terms defined. Because sometimes you cross fields, you find that in different fields they use the same term and they have different definitions. Plasticity being one, where like in the brain or in neuroscience they use plasticity in one way, and they talk about like neural connections and the birth of cells, and in physiology it's slightly different, and then in material science it's totally different. They say plasticity, but they mean like plasticity of materials, and it's a totally different set of mechanisms. So it's very important to have those terms and sometimes to spell them out. So that's always a good learning tool. And then Jesse points to representational brains and phenotypes as the project. We talked about that last week, that site. And then Sadna asks, have you guys done work related to the peripheral nervous system and autonomic nervous system functions in metabrain models? We haven't. We're kind of, that's what we're kind of doing in this paper. We're not there yet. We want to do that. I guess we wrote in the paper we wrote in the first paper that's on the archive. We talk about representation as like sort of a brain that's this mental representation of like sensory information and things like that. So it was very much like in the central nervous system. In the case of this paper, we're actually interested kind of in this moving to the peripheral nervous system or the autonomic nervous system. The peripheral nervous system is interesting in a lot of ways as well. Like, if you think about your reflex arcs in your leg, when you go to the doctor and sometimes they'll hit your knee with a hammer and your leg twitches like that, it goes up. That's a reflex. And those reflex arcs are actually sometimes don't even have anything to do with the central nervous system. It's all processed locally in the peripheral nervous system. And so there's a lot of stuff going on in the peripheral nervous system, a lot of relays and things like that that are very key to that system. And so, yeah, we're definitely very interested. And I think there's a lot of work to be done in terms of understanding those systems, like the peripheral nervous system, the autonomic nervous system, which is like your sort of regulating your internal state, your gut, your, I guess proprioception is technically the autonomic nervous system and things like that. So, yeah, there's definitely room for that. Yeah. So,
one thing I wanted to say that was in the chat and we kind of kicked over for a bit. I mentioned after Ankit said, "Oh, this would be a great thing to go over terms," and I said, "Yeah, like if you're someone totally new and you're unfamiliar with terms, but you're interested in something, and you don't really know yet what to present on a workforce, you can write a simple article or like blog post about a term. Like you can go over genotype or phenotype if you want to, and just like as a very simple, like 1 page or less, minimal overview, just to get practice in writing something very simple. Like don't be like, that's a totally acceptable thing to do. Like if you're starting out, or you're like, geez, I'm really interested in this concept, it can be very, very, very simple. And I just posted a link to Plato or the Stanford's philosophy encyclopedia, and that's like a lot's going on there. This happens to be embodied cognition, but the topic itself doesn't matter. But like, that's a great reference, and we can point you to a lot of references and resources that maybe will, like, you can read a little bit about something that we send your way, and then you could write that simple blog article. So just as a very, very, like, a very first step in something, if that's something you want to do, like, don't feel like, like if you don't feel like you're ready to talk about things at a level that Brian did earlier, that's totally fine. There's no expectation that you have you're doing it that way. So I know this happened, but like I want to just totally address that. And so making a simple article or a presentation, whatever you prefer. So maybe you don't want to present right away, you just want to write something. Like don't be put off by having to create something very large. A very simple blog article, that would be totally fine too. So just to emphasize that. Okay. What else did you want to talk about next, Brad? I know this meeting is going by so fast.
Yeah.
There's so many more things that.
Well, I mean, I just wanted to kind of go over maybe another thing that we're submitting, and I'm going to do this in like 2 or 3 minutes. So another thing we do is we submit talks. So, I said before that we have the submissions document here, and we have like papers that we generate by a certain deadline. Sometimes we submit an abstract, which is a lot shorter, and then we get accepted, and then we have to produce a talk. And so we actually have, and I don't know where it is in here, I don't even think we have it on here, here it is, the EI workshop. So this is a thing that we did last year. This is embodied intelligence, which is what EI stands for. And we submitted some topics here. and I submitted something under my name, which was this something called developmental offloading, and Jesse submitted something which was the embodied agent taxonomy, which she's interested in developing, which is something, again, dealing with terms and defining things in terms of, like what we talked about with embodiment, and there are all these terms that people throw around, and we need to define them. So that's something that he's going to be working on. But I have this, and this is a good example of how you can become involved in something. So Angela Arias, who's not here, she's in the group often. You'll see her in the Slack, and she's in there, and she talks about, she's interested in a lot of things. She'll be in the Ethics Society channel. She'll be in the, well, she's interested in a lot of different things. But this is one of the things we worked on I think it was earlier last year, this idea of a developmental model of intelligence offloading. So this is something that is where we have this again, we're doing this agent-based model, and we're looking at how agents will behave in an environment, but also how they'll offload information into the environment. And this is just like a nice little gift that I put in this talk. It doesn't have much to do with, it's just kind of a nice, cool gift that we put into the, one of the key things about giving talks is you have to design your slides to be compelling. So, but the idea is this agent is developing a phenotype or a body, and then that body takes a certain shape on, and it shapes its behavior with the world. And it has a brain inside of here, which we don't show. But it also interacts with its environment. So in this environment, which is an alien world, it's having to use things like the stars, the sun, the mountains, this lake that you'll see down here, all as like landmarks. And it can take information and encode it in the environment as well as in the brain. So, you'll see like stars as an agent. You'll be able to navigate by the stars. You'll be able to navigate by the mountains here. And you can put all that information in the environment, and then your brain will make the connection between things. That's the idea of offloading or intelligence offloading. And so, when you write something on a piece of paper, that's intelligence offloading, because you're putting that information outside of your brain. It doesn't require you to store it in your brain. And so, like a lot of AI nowadays, doesn't really talk too much. They don't talk too much about that. It's all this neural network processing, or, we talk about agents, and embodiment is a means to sort of get around that sort of processing limitation, saying that the body is important. But also this being embedded in an environment that you can use to place information out into the world is also important. So Angela and Jesse were involved in this. I solicited, an abstract, and I said, would you like to join in? You can contribute to the abstract, contribute to making the talk. They said yes. So we go, we have all these different things that we've cited. We have this thing from Andy Clark, which is this example of offloading where he talks about the bluefin dolphin, which is a dolphin that uses vortices in the water column here when they're swimming. This is a vortex in the water that they use to improve their swimming capacity. I don't know if they create this vortex or they find them, but they use this change in water pressure, I believe, to improve their swimming capabilities. So they're using this thing in the environment or they're putting things out in the world that improve their performance, something that you would expect it to be a purely physiological thing or purely a brain or neural thing. So there are examples of offloading, and we talk about that. And we talk about sort of, offloading as an intelligent embodied system. So we're going to get into the aspect of innateness, the aspect of affordances in the environment. These are all terms that, again, we don't define them in this talk because we're presenting to a friendly audience. They know what the terms mean. But that's something that, we can, if we want to, define those more clearly in, say, like a paper. And then there's these connections to agents, to neural networks. Then there's this model of developmental trade-offs, which means that when this agent is developing, There's certain things that it's taking into account. There's this energetic budget that it has. There's a rate of brain growth, and there's a rate of information acquisition. And what happens is, it basically, depending on the environment, those things are contributing a certain amount. So the less energy an agent has, the less brain growth it can exhibit, and then the less rate of information acquisition. So that's how that works. There's a trade-off between energy, available energy, and brain growth, or available energy and information acquisition, or brain growth and information acquisition. Information acquisition being things in the environment, brain growth being what's going on in the brain, and then the energetic budget is how much energy is being put in so that it can develop fully. And then these have different outcomes or consequences. So that's our basic model. And so we worked on this presentation here, and this is, supposed to be like 15 to 20 minutes. So a lot of this is like, going into the literature, finding out what's going on, building a model, and then demonstrating it in these slides, and really making them compelling. In the lab here, we have some graphics that we recycle from talk to talk. So these vehicles are something we've, have in other talks. We recycle them to new talks, and they just, make the talk look good. They make it have a certain visual style. And so, my point here is that not so much on the content of this talk and showing like a lot of the detail in here. It's, there's a lot of stuff that goes in, but to show that, like, this is the way we organize these things. We have to kind of consider a lot of things. We have to get the information down, boil it down to like 15 minutes, and then, makes it this, and then you always have the slide towards the end where you really kind of put this out there. You kind of put an idea out there that is really exciting, but you don't follow up on it necessarily. So in this case, it's the developmental learning of celestial navigation. So this is where we have a problem and this is just something we don't solve, but we kind of put the marker down. And we say, you have these agents, and these are just examples here, that are developing. They're coming from these eggs that are hatching, and they're developing a phenotype, and this is the adult phenotype. And as they're developing, they're observing the stars, and they're using the stars to navigate. Okay, this is what organisms do, actually, not just humans, but other organisms will use starlight and star points in the sky to navigate around their environment. And so the idea is, could you build a model in a computer where you have these star fields that came up above them, and then they could learn position and orientation and navigate using these markers. So they're offloading all that information about the map out into the world, and then they're just using their nervous system to make those associations. So that's the idea. And then that's an example of a talk that we have, that, something that would go to a conference, something that is, something we can recycle to another set of audiences. And again, we'd have to modify it, we'd have to define terms, we'd have to change the language of it a little bit, the graphics. But that's the process of making a talk. And we can get more into that in more detail as people want to. People can, contribute. We can talk about contributing talks and, collaborating in that way. So just wanted to show you that as well. Do you have any questions about that, or? Okay.
It's pretty cool stuff.
Yeah.
If is there anything else you wanted to say? Because I might rapid fire through a bunch of updates because I want to.
Yeah, I think we can move to updates now. Why don't we do that?
Okay. Because someone said this week in an event I attended, they did something that I wanted to normalize for a very long time, and they said, "Okay, this is a great time." Like they were really impressive. I really like this. Like, okay, this is a great time for questions. And then we asked the question that said, okay, before we go into like the last part of the talk, we don't stretch and move enough in academia, so I'm going to take a break to just like stand up and move and like even like 30 seconds of like rotating and whatever you want to do. Like if you want to take that break right now, do that while I'm talking, because I'm gonna like I don't encourage this as something to do, but like I have to say some things in this meeting so we can talk about more things next time. So I'm gonna go really fast through a bunch of stuff, and maybe even if you're like sort of passed out in bed and listening, like just uh, bend your neck to one side or another, something like that, just to like loosen up. Because after that, I'm going to be going, and I'm going to try to share my screen and go through this stuff right now. So that was your be embodied in yourself comment.
Yeah.
Great. And now let's see if this works. Oh no, is it sharing?
Yeah, you can see
it.
it.
Is right? No.
Yeah, it's sharing.
Oh, because it didn't last time. I had to restart a bunch of things. Okay, great. So here is my Obsidian thing, which is great. I have a bunch of. I'll explain all this other stuff at some other point, but for the time being, I'm just going to rapid fire through this stuff. Quickly, my overview is going to be, these are a bunch of talks I attended basically in the last 2 weeks. It's a lot. And I made some notes with all of them. And what's great about using Obsidian is they're really easy to get to. I can just go there, and you can see my notes in the talks. But there's a boot camp that I have myself into that's very low key. I don't have any notes I can show about it, but it was really interesting to hear a lot of people being really open to. I kind of came in heavy from like if we're going to talk about if we're going to talk about AGI and like how it's going to happen, I'm like, well, I kind of went in hard about like, well, let's talk about embodiment and whether or not artificial agents need to be embodied to have intelligence. And I kind of referenced a little bit of the Isabel and Barrett stuff and other things, and it was really well received. I was actually quite surprised because sometimes people who care about AGI and AI safety are like really disembodied folks, and they don't care about agents. They just want to have more computational power. That's all I'm going to say about that. Just as another disclaimer, everything that I say right now is not something to go deep into, and I'm not even going to try. But it's like, if this catches your attention, please message me after today's meeting, or if it's sending me in the Slack and we can follow up on it. This is just saying stuff really quickly so I can say it and not forget it, just in case it's of interest to anybody else. 2 weeks ago, I attended an ethics meetup on MIT's campus, and this was pretty cool. This was about modeling users of machine learning systems, deferral, and teaching humans through examples. And this has a lot of tie into a lot of the things that we talked about in terms of, maybe talks about like empathy and some social aspects of AI stuff. This was specifically actually in a healthcare setting, looking a bit at how to train a user to deal with an AI system, and when that AI system may flag something to say, okay, I'm pretty confident about this, but not about that. The system would recommend deferring to an expert, and also how, as a human user of that system, how to train them to be familiar with what the AI system may or may not be good at. And there's the whole like sort of representational metacognitive approach of like how is a human dealing with what they're sensitive to the AI system can do or not do. Again, there's a lot of interesting things in this talk. I have a lot more I could say about it, but in the interest of time, if that sounds cool, please follow up with me about it, because there was a lot of very interesting things happening there. Okay, great. Timna Jabru, this was a great talk. I'll probably say more about this in the future. I got to be able to see some of her. For the first time, I could see her in like a really candid setting, and because she was just like super honest about what happened with her at Google and how she made her own research group. And she's a very very valid critic of a lot of things that are happening in technology, and is very respected. And she's kind of fortunate because her respect and renown made it easy for her to get funding to do things that weren't beholden to a lot of corporate interests. And that's a whole discussion to have for another time. But more about that if you're interested in AI ethics and data stuff. Abiba Birhane was mentioned, and I was super happy with that. She's one of my favorite AI ethics people. I think I have a. Can I pull this up here? Just really quickly, there's me, and Timothy Brew is like over here, so I'm like next to her virtually, and yay, that's my fanboy thing for the day. But she made BARR, and she built a research group around community and not exploitation, and around healthy and thriving researchers, which is very not normal in a lot of how we go about things. And why she did that is a really interesting story. Principle, process, and pragmatic approaches. More about this some other time, but just really cool stuff and really cool stories to go at some other time. Really quickly moving along here as fast as I possibly can. That was that talk. This was a really cool thing and had actually ties all the way back into an A-Life paper, but this was about AI safety and the most, this is straight up AI safety as it is now. This was a talk also at MIT that I happened into. But it was about, it was called The One Thing to Fool Them All, Generating Interpretable, Universal, and Physically Realizable Adversarial Features by this brilliant guy, Stephen Casper. He's working on, his talk was kind of an overview of methodology in machine learning and computer vision stuff that can help with interpretability and creating like a very interesting, let's say, adversarial set of topics. But one of the papers he mentioned was actually this paper, which I think Bradley has referenced before. The Surprising Creativity of Digital Evolution. Have we talked about that? I don't remember.
Yeah.
But it's an A-Life paper, and you know, it was quite a cool thing to see come up here. There's a lot of details and different methodologies. I don't know a whole lot about it, but I took as many notes as I can. It sounded really cool. But I'll mention that maybe to Brian because I know he's interested in that. And this may come up in some of our AI ethics talk later at the conference. And then I took, there was some updates from the Johans, I think this is calling it now the Multiscale Neuroscience Journal Club. I took a number of screenshots here. I think they're going to work like this. Yeah, here was the intro. It was going over Paul Kazdick's paper, Evolution of Behavioral Control from Chordates and Primates. And this is, yeah, look, that's pretty badass and cool to me. That was what it was like in the Zoom. These are super cool images, the phylogenetic refinement image, and sort of how things have developed over time evolutionarily, and this other chart from Paul Kazdick, which is really cool to see like how major infrastructural changes in biology. And again, I'm not an expert in all these things, so don't feel like you have to know this stuff, but just kind of, if you're interested in any of this stuff, please reach out to me and I can sort of hook you up with that stuff or more about like Johan's group and things like that. But I just wanted to mention this really quickly. I may talk more about it later. It was a really cool talk, and they're all recorded and they're all on YouTube, which is awesome. I have some specific project updates that I'm going to do, and then also a really quick run through for Twitter that may affect some different people. I thought of with a lot of different things in Twitter updates this last week. Take my breath for a moment. Let's quickly talk about New Exploration Domain Computing. The status right now is we have 45 minutes, which is a long time and a good amount of time, but not that long because we have so much we could talk about. We have like 30 minutes of presenting basically to aim for. I know Bradley wants to do a general lab overview and some other talk. I think that he mentioned was like a flash talk link. Correct me if I'm wrong. Does that sound right, Bradley? Or
Well, I think that, yeah, I mean, it's something that, I mean, I was the impression that we're all going to contribute something. So I can contribute a couple of slides on like the stuff that we're doing with the Summer of Code project. You know, that's sort of aspirational. But yeah, I mean, that would take, you could stretch that out to 10 minutes or boil it down to 3. It's, you know, it really is,
yeah. I'm gonna say, like, for the time being, let's call this. Let's say we have about 20 minutes, 20 to like, I don't know, 18 minutes scheduled. So we could get like 1 or 2 or 3 more, 1 to 3 other flash talks ongoing. Depending, I want to confirm how long Angela thinks she's gonna be. Because she could talk the whole time, but I want to figure out what she wants to shoot for that. That's kind of our centerpiece. And I know Erin has been working a lot on this paper. She was talking about, she can't be here today, but she is working on this. So I imagine that's going to be at least maybe like a 5-minute talk. So depending on some of the length of these things, there's some other, like, if you want to have a segment to do like a flash talk within our overall presentation, and you're interested in that, or like have an idea, or you'd like to join one of these other topics, and feel free to ask more about that in Slack anywhere. Just putting it out there, this is all happening, and this will be a lot of interesting experience if you're interested in anything about those areas. But that's the overview right now for that. That's all. This is definitely happening, and we have a month or so to flesh it out. Any questions so far that I should answer before moving on to some other stuff? Slack? Oh, no. Okay. Okay, cool. All right. Frontier map, I might even talk about today, because I'm kind of other things immediately to talk about. Let's quickly go over Twitter as well. There's a few things I wanted to mention quickly. There's a talk next week with a lot of really interesting people. Oh, Lex Friedman's going to be there too. But Yasha Benjo and Jan LeCun are major people in machine learning stuff. Basically, you know, it's going to be very Facebook friendly or meta friendly. But what's happening in the metaverse? And there's a lot of things that are going to be going on in. It's going to be a really hot topic for a lot of things we're talking about, from cognition to AI to psychology to virtual environments to how human-computer interaction, human-robot interaction, virtual communications, so on and so forth. If you're interested in this, it's a free thing on Facebook, literally streaming on Facebook. I'm going to go and be happy to talk about it. So if you want to like go and talk about it, or maybe present an idea you take away from it next week, definitely an option. Really quickly going through Tony Shimero, who is very much about embodied cognition. Really interesting talk. Mentioned, I think, partly by one of our external collaborators, Charlotte, in the UK. Perceptual consistency over time, I believe. A very interesting topic. Can I see this? No, nothing there. Going really quickly through all this stuff. Hey, we got accepted. Proud. Go us. Gary Marcus. Looks quite interesting in terms of a podcast. If you're interested in some of his work and robust AI and cognitive science and AI from a more cognitive science perspective and what he's advocating for, this might be a great thing to check out. Timothy Jabru, really cool. Darwin Day Post. And I wanted to mention Eric Hole's stuff. He's a really interesting guy in the philosophy space. Amanda might be interested in him, or I've heard of him. But he's written an article, a little post about how we're dealing with AI, and maybe even actually Sam with some of her empathy and AI stuff. Let's check this out if I can see it quickly. But I can't really explain this quickly right now, but a really interesting, he does a lot of interesting work in how we are thinking about ourselves and, let's say, technology. And also from Eric, there was a discussion about dreaming and how dreaming as data augmentation. Charlotte was at this talk and mentioned it generally and to me. I haven't looked at it specifically, but it looks really, really, really interesting. And if you're interested in more of the dream, psychology, metacognition aspect of things, maybe check this out. This is all on my Twitter, but if you have any other questions, let me know and I can throw this at you. And then a really cool talk from Conrad Cording about where is AI going in the role of neuroscience. That might be relevant to some people interested in the neuroscience component of things and merging that with AI here. Conrad's a great person and involved heavily in NeuroMatch, the conference and summer academy about computational neuroscience. And he's very progressive in his ideas about education as well. So I think that's my rapid fire tour. Thank you for letting me throw all the information at you. And again, please don't feel like you have to know it, but if anything caught your mind or attention, reach out to me and I can more intelligibly speak to you about it. And I'll leave it at that.
Okay.
If you, I'll put it at my Twitter if you wanted to see any of those links I mentioned on Twitter, because they're just all there in my recent timeline. So,
thank you. Yeah. So I thank you for that. Sadna had to leave, so thank you for attending. So yeah, that's great. And these little updates, or sometimes I'll present something. They're kind of fragmentary in that we don't have lots of time to go over something. So if you find something that you're interested in, put a pin in it and say, bring it up maybe in the Slack and say, I'm interested in this thing that we talked about. And then we can talk about it more. Maybe follow up next week. It's like kind of drinking from a fire hose in some ways, but it's also that you want to pick and choose what you want to focus on. So not everyone is going to be focused on everything, So again, please, if you find something interesting, let's talk about it more later.
Those things were definitely not something you should all know every detail about. I kind of did that intentionally for people who are maybe in the process of looking for leads for their own research projects. Some of those things may be interesting to follow up on, but don't have any sense that you should know all of those details by any means. Okay, I know we're getting close to our time.
All right.
So
let me see. I do this thing at the end of the meeting where I do papers. I go over some papers that are interesting that I've found recently. So let's see if I can find some things in our folder here. So I've been moving them out to Fermat's library as well. I don't know if I'm gonna bring that up, but in Fermat's library, you can, which is a platform that has they basically feature papers that you can annotate. So in this, for example, this paper, you can upload a paper that's a PDF, and you can annotate it by clicking on something. I don't know if it's going to work here, but it'll basically allow you to annotate different parts of the paper, and then you can share the annotations with people. So all right, here it comes up. So you can use LaTeX and Markdown to format text, which are different different programming languages that are sort of they're not really full-blown programming languages. They just allow you to write equations and other types of formatted text. But if I want to make a comment in a paper, I could upload a paper to this platform and then make comments, and then we could do this across collaborators, and you can really kind of make comments on different papers that way. I'm not going to go into that this week too much, though. So I guess we talked a long time ago, before a lot of you were even in the lab, about something called Grossbergian Neuroscience. And this is, again, something from Stephen Grossberg, who's a famous neuroscientist. Johann John is actually the person who is, like, I think he studied under Stephen Grossberg. And I just wanted to bring up a couple of papers here that were interesting I found this week. I was actually checking out their YouTube channel when I was like looking at some of the interviews that Grossberg has given. He's a retired professor. He's still alive, but he did a lot of really interesting work in his career on neural networks and AI, but from a cognitive science perspective. So he's interested in like the different, the capacity of neural networks to model the brain or to model, feedbacks and things like that. He's much less interested in the machine learning aspect. This is a paper that I found that he mentioned in one of his discussions that I think is really interesting, because I said before that we do this stuff with developmental biology in the DevaWorm group. And this is actually his approach to taking like his ideas from the brain and applying it to developmental biology. So there's a lot. This is a really interesting communication, memory, and development. It's a very generic title, but and you can see that it's a fairly long chapter. It's like 35 pages. So there's a lot of stuff in here. Basically, the idea is to make the connection between these two areas. So he's introduces a number of concepts here: noise versus saturation, the statistics of switches, gain, control, and adaptation, in on-center, off-surround networks. So this is an idea from visual processing where you have these perceptive fields, and there's like this variation in how they're activated in an array. You have different types of memory that are, in developmental biology, we don't really think about memory in the same way that like we think about it in the brain. But maybe there are connections there that are really interesting. For example, an embryo doesn't necessarily have its own nervous system, right? I mean, you have a nervous system that's forming in the organism, but it's not like the imperative of the embryo to have like some sort of consciousness guiding its development. This is all what they call self-organization. But nevertheless, there are a lot of mechanisms in developmental biology that mimic what the brain does in terms of making sense of patterns in the environment and interpreting these things. And so there are a lot of different mechanisms that he talks about and proposes. There are all sorts of things like slow waves in pacemakers, reaction to fusion models, regeneration. So there's an analogy between regulation and adaptation and regeneration that are very interesting. So this is an example of a paper where you're going from like one area and you're kind of going to another area and you're looking at it and you're reinterpreting what's going on with some of the tools that you're using from neuroscience. So he's taking computational neuroscience and using it to better understand developmental biology. This paper is from 1978. So this is something that is been around, this has been around for a long time. I've never even encountered it until now. So, and I'm pretty well read, I guess. So, you're always finding new things is my message there. It talks about things like biochemical memory, slime molds, slime mold aggregation. So slime molds are these collective structures. They're molds. They have, a bunch of cells that are doing things collectively. They're aggregating and then they're moving around in a mass that's, in a directed manner. So if you saw a slime mold, you might think it had a brain. You might think, well, that has a brain. That obviously has goal-oriented behaviors with a brain, with a central nervous system. But in fact, they don't have a central nervous system. They have a bunch of cells that are acting in a way, sometimes in response to chemical cues, sometimes just, in following their neighbors, that forms these nice aggregate directed behaviors. They're not guided by a central nervous system necessarily, but nevertheless they exist and are produced. And so, there are all these things that is exploring one of the central questions of developmental biology is, how do you get organization from what essentially is nothing? Like, how do you get cells that move around, and you get these collective behaviors between cells? They kind of find their location in an embryo. They go from this mass of cells to a phenotype that has different parts, like a head and a tail and gills and things like that. How do all those things form? And so, this has been an outstanding question for people, and bringing different things to bear here is important because we need to have sort of a basis for mechanisms. And so, this paper, I think, or this chapter, really kind of dives deep into this, and kind of takes a really nice shot by using what we know in neuroscience and in computational neuroscience to sort of propose some mechanisms for this. You have a lot of different topics that are followed. So this is like one of these tour de forces. He doesn't just take a small chunk of the area. He just goes for everything here. This is an example here. This is a 1978 example of what the cortex is doing when it looks at a picture. So a picture is interpreted by the retina. There's some filter, a statistical filter, and then there's this feature detector within the cortex in the brain and the central nervous system that detects a feature in this picture. Now, since 1978, this is a very simple model. This has become much more detailed. So, you have very, very complex machine learning models that basically operate on this circle and box model. So, like, this whole circle and box model is very, can be accentuated a great deal by modern, machine learning models, but the basic idea still stands. And you can also make connections to development with this kind of pattern recognition. And so that's a nice thing. Ankit and I did a presentation on switching, I think at the end of last year. And Ankit said, I really like that, what you're saying. And this is the statistics of switches. This is something that happens in the brain. He's generalizing this to developmental biology. And I did a presentation where I really made a general cast of, this idea to a lot of different systems. And so Ankit got turned on by that. And so we're actually working on a theoretical paper on switching, which is basically the idea that you can take a system and it can be shifted into different states by a simple mechanism. And so you see this in gene expression, you see this in the brain, you see this in behavior, you see this in a whole host of areas. And so the question is we see this simple mechanism, we see these behaviors, can we boil it down to a fundamental sort of computational mechanism? And what can we say about it? That's the idea that, we're trying to, when we say something about switches, we're not talking about light switches, we're talking about these mechanisms that we sort of make up from the data. We sort of interpret it, and then we use like a physical model or something as an analogy. And then we kind of work out maybe what that means in terms of the mathematics. So there are different, mathematical formulas you can come up with that describe these switching states, these switching mechanisms. There are also other types of ways you can characterize it, like there are different mechanisms, like there are different cybernetic regulation mechanisms, things like that. But you can, once you get, basically what you do is you observe a system, and you might observe a number of different systems. So you might observe what's going on in the brain, what's going on in a developmental context like an embryo, what's going on in like slime molds. And you might look across all those systems and say, there's this thing that's going on that they're like maybe persistently and randomly switching their state from like the slime mold might switch its state very distinctly. The brain might switch its state from like one set of activities to another. There are all these different ways that this happens, but we hypothesize that there's this common mechanism. And so this is what, people This is how you build theory, right? You say there's a stuff that's interesting in the world across a bunch of different systems. What is it that's going on that they have in common? And then you build this model that captures that variation and explains it. And sometimes it's successful and sometimes it's not. You can publish on different ideas, and most ideas, don't really get a lot of traction, but that's okay because maybe someone takes it later and uses it for something else. It doesn't really matter. Just don't be discouraged and think that, well, no one will care. Well, this paper has been around since 1978 and I just found it. So I don't know, but it's still worth doing. It's so it kind of gets into some of the stuff with making the connection between the brain and then like some things in development, which have some really remarkable parallels. And I'm glad that I found this because in the DeviantWorm group, we talk about these parallels all the time between the nervous system and the developmental system. There's a person called Michael Levin who does a lot of this as well. He looks at electrical activity in the embryo, and he kind of makes the analogy to a brain. The electrical activity in developmental cells in embryos are different than what goes on in the brain, but they're actually quite closely related in some ways. And so he's making that connection between regeneration of a phenotype or of cells in their organization, and then making the connection to what neural networks are doing in the brain, or sometimes what neural networks are doing artificially. So yeah, it uses a lot of things like sigmoidal functions, which are used in neural networks and neuroscience to kind of explain what's going on, some of the things in development. And then, some mathematical tools like looking at statistical physics and things like that, peak shifts and hysteresis. And these are all things that, kind of laying out these details from his area of expertise and kind of applying it to things in biology and in development. So it's a really interesting paper. I'm glad I found it. But he's also got another interesting paper from 1978, which was a more direct theory here, a theory of human memory. So this is actually where he lays out this theory of human memory. And he builds on this idea. I guess he's been working on these kinds of things. This is a psychophysiological theory of the self-organization and performance of sensory motor codes. So this is just kind of works out this theory. And when you do theory building, and this is something that I've been trying to do in the group, but I haven't really gotten a really good set of materials on. But there's this process of theory building where you kind of get into this idea, you want to build a theory of X. And the theory of X usually has a lot of components. So it could be like you have to explain human memory. You have to have a lot of different variables that you have to put into your model, and then you have to figure out how they're related, and then you have to figure out how they generalize. So a theory of human memory is nice, but if it's just a theory of, say, episodic memory or declarative memory, then that's not really maybe good enough. You want to have a broad theory, something that explains a lot of different things. So, I haven't really developed those theory building materials of my own. There are some theory building materials, if you're interested, we can talk about. But this is a nice paper where he goes through this theory of human memory. And people have done this in the past. This is not the only person doing this. So yeah, he just kind of gives a lot of examples of different things, spatial patterns, chunking of information. He lays out all these things in memory. And then he kind of goes through some computational models that are interesting in how they apply to this theory. And so, this is 70 pages. I'm not going to go through the whole thing. But it really kind of lays out a lot of these things. So you need for theory building is you need to have you need to have a set of ideas about the area that you want to tackle. And then you want to have some other, you want to have some variables that you want to define and how they're related to one another. And then you want to have this, be able to generalize to different things. So you may have to bring a lot of things to bear for your theory, but that's how you build a theory. And I like this paper because it really kind of focuses on an area, but it's also very general. Okay, that's all I'm going to talk about for today. There are a lot of things in the chat here. I don't want to go with, well, we have a couple things here. I guess Shaima had to leave. Thank you for attending. And then Jesse has some annotations here about some of the comments for later. Johan has noted how Grossberg stuff has never really been modeled computationally.
I'll just say, like, go ahead. I'll just say, like, Johan, I was thinking this myself, and he explicitly stated it in one of the meetings. But like he did a whole series on Grossberg's most recent book, because Grossberg put out a book after a long time just recently, and they went through it. And Johan and a bunch of his former students that from Boston were going through his book and talking about their experiences with the material, and also some anecdotes, more so off camera or like not reported about Grossberg and other things. But like Grossberg kind of fits in that category of someone who's really brilliant and came with a lot of ideas, but a lot of his ideas and big and remark like Bradly just said, not really a lot of people know about some of his less popular ideas or this paper perhaps, but they were never really given. There's a lot more opportunity now to explore with areas and try to model them and build things out. So a lot of things that happened sort of before the turn of the century, there's a lot of ideas that have come. There's a lot of ideas that have never really been put together, and there's a rich, stockpile, sort of like buildup of material. I think like fossil fuels building up, but like intellectual material building up over time that haven't really fully been mined yet, particularly in an innovative and cross-disciplinary, intricate approach. So that's kind of one thing that really turns me on and why I made Cognition Futures. It's kind of what I'm hitting at in the next part. So if there's depending on, I'm not saying everybody has to go down that path, but like if you're interested in things along those lines, like that's part of my motivation as well for Cognition Futures. But regardless of my topics, like for those of us who are getting into, looking ahead at research, I think it's an old saying that the areas between the core disciplines are where there's a lot of room for growth. Yes, but I think there's a really cool, perspective to have when you're looking at where do I find ideas that I want to build upon and flesh out and test and do my own remixes of them. This is a great example. So yeah.
Yeah, that's great. And you had a comment here. I think this is what you kind of paraphrased about Cognition Futures. So yeah, building out a lot of ideas that have been built up for a long time and testing them. So yeah, I mean, a lot of ideas had been proposed, theories have been proposed, but you couldn't test them on a computer until recently. This is the case for a lot of in artificial life, for example, where you had ideas that people had about simulating life, but you didn't have the computational power to do it until very recently. So there's a lot of stuff in the literature, if you go back 30 or 40 years, it's been out there that hasn't been put into a program, but also hasn't just put into theory because you couldn't test it in any meaningful way. So I mean, and this goes also for the brain, because we have a lot of brain imaging tools now that we didn't have back then. So you could look at the brain in that way as well. You could go and look at neuroimaging data or something like that we have now. We have the data sets. So you could actually go back to those ideas, set up you could even go get the data from a public repository and look at and do some analysis and actually make some really interesting progress on that. Okay, so that's all I'm going to say for now. Thanks for attending. I know some of you had to leave early, but that's fine. Next week we'll continue on with some of these ideas. If you have some things that you found interesting from this week, please pin them and bring them up next week. Maybe we'll have some more updates on things, on people's progress, and like I said, just keep going and making momentum. It's the most important thing. Don't worry about whether you're right or wrong or you have these really polished things. Just just make progress on it.
Yep, and exactly that. And if you have any questions at all, or I threw a whole lot of information out about links and stuff, please reach out in Slack. Or if you have an idea that we didn't talk about at all, and you're still curious about it, mention it in Slack, and Bradley and I will follow up. Thank you for sticking with us here today, and also in the internship in general. And if there's anything we can do to make it a more rewarding experience for you, let us know. But otherwise, it's a 3-day, it's a holiday weekend for me, and hopefully it is for other people. Enjoy that, and if not, enjoy your regular weekend too. And thank you so much. I'll be around, and yeah, this was great. Happy to have you all here.
Thank you for attending.